CBSE Mathematics Class 12, Exercise 12.1, Question number 5. Maximize z equal to 3x plus 2y, which is our objective function, and subject to x plus 2y less than 10 and 3x plus y less than 15, x and y are greater than or equal to 0, which is non-negative restriction, and these complete, which is mentioned as a subject to, are known as constraint. Now first of all we will solve it. x plus 2y is equal to 10. देखिए x plus 2y is less than 10 है, हमने इसको सॉल्व किया in order to find the intersecting point. So it will be equal to 4, x will be equal to 4 and y will be equal to 3. So intersecting point will be equal to 4 and 3 for these two equations. FR stands for the feasible region. Now we just plot the graph, and as we know that x plus 2y is less than 10, so the arrow mark indicates the region which fulfill the given inequation, that is x plus 2y is less than 10 or equal to 10. So this BC and the arrow mark indicated downwards is the region, and 3x plus 15 is also less than or equal to 3x plus y is less than or equal to 15. So again I have indicated the feasible region by arrow mark. So overlapping region means which is combined by these two graph line is the feasible region, and its corner points are 0, 0, A, that is 5, 0, B, that is 4, 3, C, that is 0, 5. So the area bounded by this corner is the feasible region. You see the corner points of the feasible region are 5, 0, B, 4, 3, C is 0, 5, and O, that is 0, 0. The corner points are arranged here. Now put these values in 3x plus 2y. Subsequently you will get the value of z. Here if you put 0, 0, you will get 0. If you put 5, 0 in this equation, you will get 15. B, that is 4, 3, you will get 18. 0, 5, then you will get 10. So the if you put B, that is 4, 3, here you will get the value of Z, that is 18. If you put 0, 5, you will get 10. So the maximum objective which we are going to achieve is that is 18 at the point 4, 3. The 4, 3 is this. So the maximum value of Z is 18 at the point 4, 3. And that's all. It is the solution of the question number 5. Now come to the question number 6. Minimize x plus 2y, which is our objective function. Subject to means 2x plus y is greater than 3 or equal to 3, x plus 2y is greater than or equal to 6, x and y is greater than or equal to 0. And this function is known as non-negative restriction. Now here 2x plus y is equal to 3 and x plus 2y is equal to 6. If you just solve it, you will get the intersecting point, and it will be equal to 0 and 3. The point of intersection will be 0, 3. Now it has been located here, 0, 3, that is C point. Now the unbounded region satisfied by these two inequation, that is 2x plus y is greater than or equal to 3 and x plus 2y is greater than or equal to 6. So the unbounded region has been represented by the shading here, which is the 2x plus y is equal to 3. This is the line, means AC line, and BC line represent x plus 2y equal to 6. So any point which lies above these lines will satisfy the given inequation. The points are corner point which I am discussing, that is B here, that is 6, 0, and C, that is 0, 3, C. Find out the value of Z, that is objective function. Here if you just put 6, 0, you will get Z is equal to 6. If you put 3, again you will get 6. So every point on BC will give the value of Z is equal to 6, and that is minimum. Above that if you go, that will be more, but the minimum, because the question is asked the minimize, means we have to find the minimum value of the Z. Here x plus 2y is equal to 6. X plus 2y is equal to 6. That is 2, 2, 4, 1, 1 and 5 by 2, 6, 0, 0, 3. In case of maximum, we can take any point in unbounded region. Unbounded region means यदि maximum लेना है any point, that will satisfy your condition. If you take any point in unbounded region, that will be maximum. But if you just take the point on BC, that will be the minimum value of Z, and that is equal to 6. Now come to the question number 7. Here, so that the minimum of Z occurs at more than 2 points. Question number 7 में minimize and maximize Z, that is 5x plus 10y, subject to x plus 2y is less than or equal to 120, x plus y is greater than or equal to 60, x minus 2y is greater than or equal to 0, x and y is greater than or equal to 0. So first of all, we just solve x plus 2y is equal to 120 and x plus y is equal to 60. So the point of intersection you will get here, that will be the 0, 60. x and y की value solve कर लीजिए, simple equation है. x plus 2y is equal to 120 or x minus 2y is equal to 0. Here if you solve, you will get 60 and 30, that is point of intersection. Here the point of intersection is 0, 60. X plus y and x minus 2y. X plus y is equal to 60, x minus 2y is equal to 0. Here you will get x is equal to 40 and y is equal to 20. So the point of intersection is 40 and 20. Here x is equal to 2y, just substitute it, then you can easily work out. Now come to the graph problem. Here, these are the intersecting point. Here 0, 0. This is your x minus 2y is equal to 0, this line. This B, C, D or O, B, C, D, this line. So here the graph is given this less than. The less than means the point below the line will satisfy the given inequation. Here x plus 2y is equal to 60 if you x plus y is greater than or equal to 60. So any point above the AD line will satisfy the inequation. Similarly, x minus 2y is greater than 0 or equal to 0. At that time, the point indicated downwards here will satisfy the given inequation. So, this is the corner points: A, that is 60, 0, B, that is 120, 0, C, that is 60, 30, and D, that is 40 and 20. Just put these values of x and y in the given function, that is objective function, that is 5x plus 10y. You will get 300, 600, 600 and 400. Here it will be the minimum. Here it will be the maximum, again maximum. The BC is the required line of maximum. Now come to the question number 8. Minimize and maximize z is equal to x plus 2y. This is the objective function. And the subject to means the constraint x plus 2y is greater than or equal to 100. 2x minus y is less than or equal to 0. 2x plus y is less than or equal to, here you see the 2x plus y is less than or equal to 200. X and y are greater than or equal to 0. This is known as the non-negative restriction. Other complete all these subject to conditions are known as constraint. Now we will find out the intersecting point with the help of two equations here, x plus 2y and 2x minus y equal to 0 and x plus 2y is equal to 100. If we solve, x is equal to 20, y is equal to 40. Here x plus 2y is equal to 100 and 2x plus y is equal to 200. Here you will get the x is equal to 100 and y is equal to 0. 2x minus y is equal to 0. 2x plus y is equal to 200. So x is equal to 50 and y is equal to 100. These are the point of intersection. Now plot the graph with the help of this inequation. Here you see the line EBA is the graph line of x plus 2y is equal to 100, and the upper part of this line will represent the region of x plus 2y is greater than or equal to 100, including this line. Now similarly, that 2x plus y is equal to 200 means 2x plus y is less than or equal to 200. This line has been drawn here, ECD. The downward arrow mark indicate the solution region of inequation, that is 2x plus y less than or equal to 200. Now here you see the 2x minus y is equal to 0 means OBC line. So the arrow mark indicate the region of 2x minus y is less than or equal to 0. So the area bounded by these corner means you see the corner first of bounded region of ABCD. That is the corner point A is equal to 0, 50, B is equal to 20, 40, C is equal to 50, 100, D is equal to 0, 200. Now substitute the corresponding value of x and y in the given objective function, that is x plus 2y. You will get here 100, 100, 250 and 400. This will be the maximum, this will be the minimum. So this will be the solution of question number 8. Now come to the question number 9. Maximize z is equal to minus x plus 2y subject to the constant, or you can say x is greater than or equal to 3, x plus y is greater than or equal to 5, x plus 2y is greater than or equal to 6, and y is greater than 0, greater than or equal to 0. If you just take first, second, third, fourth, here I have taken it x is equal to 3. If we are going to draw the line, x plus y is equal to 5, x plus 2y is equal to 6, y is equal to 0, that is x-axis. Here x is equal to 3, that will be the parallel axis, parallel to y-axis. Now solve x is equal to 3, x plus y is equal to 5. You will get x is equal to 3, y is equal to 2. If you solve x is equal to 3, x plus 2y is equal to 6, here you will get x is equal to 3, y is equal to 3 by 2. X is equal to 3, y is equal to 0. Here x plus y is equal to 5, x plus 2y is equal to 6. If you solve these two equations, you will get x is equal to 4 and y is equal to 1. X plus y x plus y is equal to 5 and y is equal to 0. If you solve here, x is equal to 5, y is equal to 0, x plus 2y is equal to 6, y is equal to 0, you will get x is equal to 6, y is equal to 0. Now with the help of these data, you can draw the graph. Here you see E, B, this point, the upper part will indicate the solution region of x plus 2y is greater than or equal to 6. This particular line is known as the line graph of x plus 2y is equal to 6. And the region indicated by the arrow mark, that will be the solution region of x plus 2y is greater than 6. Here the line which is parallel to the y-axis, that is x is equal to 3, x is greater than or equal to 3, means any region which is lying between this side. Now here I have drawn the minus x plus 2y is greater than 1. So minus x plus 2y has been taken 1. Now let us discuss further. The corner points are A, that is 3 and 3 by 2, where the value of z will be 0. B, that is 4 and 1, that is minus 2. C, that is 3 and 2, 1, that is maximum. Here E is equal to 6, 0, that is minus 6, minimum. So the feasible region is unbounded. Therefore, the z is equal to 1 may or may not be the maximum value. For this, we graph the inequality of minus x plus 2y is greater than 1 and check whether the resulting half plane has the point in common with the feasible region or not. The resulting feasible region has the point in common with feasible region. Therefore, z is equal to 1 is not the maximum value of z. And z has no maximum value. Here FR stands for the feasible region. Now next question, that is question number 10. Maximize z is equal to x plus y subject to x minus y less than or equal to minus 1, minus x plus y is less than or equal to 0, x and y is greater than or equal to 0. This is non-negative restriction. Now we solve x minus y is equal to minus 1 minus x plus y is equal to 0. Here if you see the a1 by a2 is equal to b1 by b2, it means the lines are parallel. Here I have drawn the graph. There is no feasible region and thus z has no maximum value. And this will be the solution of question number 10. That's all.